Welcome back to a new video. This video is going to be about neural network components. This video is going to be one of the videos that I will be adding into the Deep Learning with PyTorch series. You can reach to that playlist from the cards of this video. Let's start coding. We are going to start with layers. Neural network layers are the backbone of our model, transforming input data through a series of operations. In PyTorch, we define these layers within the init method. So I'm going to start by saying import torch, and then I will say import torch.neural as neural network, and then we will say something like class simple neural network, and we will say neural network.module, and then we are going to say super simple neural network and self, then we will use init like this, and then we are going to say self.fc1 neural network.linear, it's our layer. We are initializing the layers. In the init method, we will say in features like 10 and out features like 5. And now I'm going to define an activation function. We are going to talk about that in a second. I will say ReLU, and it's going to be neural network.ReLU like this. And then we will say self, our second layer. I will say neural network.linear in features 5 and out features 1. You can think this in features as input and out features as output. So okay, let's talk about activation functions. Activation functions add nonlinearity to the model, enabling it to learn complex patterns. In PyTorch, we apply these functions within the forward method. So our second method is going to be a forward method, and we will say actually, we missed a step in here. We need to define the first method, like define. And then we will say init and the self in here. And then we are going to just add a block in this, like this. And this part is going to be in this init method. And then what we are going to do is we are going to say define, and we will say forward. We will give self, x, and y, but we are going to set the y as none at the first step. And then what I'm going to do is I'm going to set the x like self.first layer, and now I'm going to apply the activation function like x is going to be neural network.ReLU like this, and then I'm going to set something like x self.second layer we have x. And now we are going to talk about loss function. Loss functions quantify the difference between predicted and actual values, guiding the model towards optimal parameters. The most used ones are mean squared error for regression problems and cross entropy loss for classification problems, but I'm going to record a different video for that. So there will be another video about loss functions. Our problem is going to be like a regression problem right now. So what I'm going to do is I'm going to use mean squared error loss. I will say if y is not none, which means if you give y when we are calling this forward method, I'm going to say loss neural network mean squared error loss. I will say x and y, and we are going to return loss. And at the last step, what we are going to do is we are going to say return x. So great, here is our simple neural network. So let's create the data and visualize it. Like I'm going to import matplotlib, and then what I'm going to do is I'm going to create a random tensor for x and y. I will say torch.random. I want it to have 10 features. I'm going to tell it like that, and then I'm going to create y, like it's going to be like 2 times, we can say x 0 like this, we can say plus 3, we can say 0.1 multiplied by torch.random number 100, and we can just call our x and y. We can see our x, and here is our y. Great, so let's visualize it for checking how it looks. I will say plt.scatter. I'm going to give the x 0 like this dot numpy, and then I'm going to say y dot numpy. And then I'm going to say like x label, x, y label, target, and we can just use plt.show at the end of this. And here is how our data looks like. Seems like pretty good data for linear regression. Great, so what I'm going to do right now is I'm just going to create a training loop which is going to train our model, calculate the loss, and optimize the model with epochs. So epochs are going to be complete pass through the entire training dataset. So if you are going to talk about the terms, batch is going to be a subset of the training dataset used in one iteration of the optimization algorithm. Epoch is going to be one complete pass through the entire training dataset where the model sees and processes every example once. And the iterations are the number of batches processed. For example, if you have 1000 examples and you use a batch size of 100, it will take 10 iterations to complete one epoch. So I'm just going to say epochs are going to be 1000. I'm going to say for epoch in range 1000 like this. I'm going to say loss is going to be model x and y, and we will say optimizer dot 0 grad like this after defining the optimizer. So optimizer is an algorithm or method that is used to adjust the parameters of the neural network during the training process. The goal of training a neural network is to find the optimal set of parameters that minimizes a certain objective function, often referred to as the loss or cost function. So what I'm going to do is I'm going to define the model and optimizer right now. I just want to show you how this starts. After that we are going to name them, like model is going to be simple neural network we created, and optimizer is going to be torch.optimizer. I'm going to use this one. We are going to talk about that later on. Model.parameters, and we are going to set a learning rate like 0.01. We are also going to talk about that in the course. And after setting this, we can just keep on going. Now we will say loss.backward. We saw this in the first video. I will say optimizer.step. And then I'm going to set something like if epoch modulo 10 equals to 0, we will say print epoch. I'm going to use an f string. I will say epoch plus 1 divided by 100. And I will say loss. I will give like loss.item, and then I'm going to set something like dot for floating like this. And then what I'm going to do is I'm going to make this run, and here our neural network is trained with 1000 epochs. Like we can see that loss is decreasing with epochs, like you can see in here. Great. So actually it was going to be 1000 since epochs are 1000, so I'm just going to make the restart in here, and I will say run all, and after that we are going to see that 1000 first epoch, 11th epoch. You can see it like this. So we can see that our loss decreases at the first step and then keeps the same after a point. So at the next videos we are going to talk about activation functions, loss functions, and optimizers. Like we have different optimizers, loss functions, activation functions. We are going to talk them in detail, and this was all for this video because this was just the introduction for these concepts. We are going to get familiar with them with the next lectures. Okay, this was all for the coding part of this video. I'm just going to summarize each concept in like one sentence, and then we are going to close this video out. The neural network layers form the foundation of neural networks, transforming input data through operations. Activation functions are introducing nonlinearity, enabling the model to learn complex patterns. Loss functions quantify the difference between predicted and actual values, guiding the model training. And the optimizer adjusts the parameters of the model during training, aiming to minimize the loss function by iteratively updating weights and biases based on the computed gradients. Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. I shared a free data science bootcamp where I teach Python, Pandas, NumPy, Matplotlib, Plotly, Seaborn, and scikit-learn with 3 projects. The video is about 7 hours and it's completely free. you can just reach to that video from the card of this video or the link in the description.